Hello, hello. Today we're going to do our first ever machine learning algorithm execution in Python. Let's go. So before we start, please like and subscribe if you like my videos, if they're useful, because that really helps me a lot. Thanks a lot. All right, to do this, we're going to first, first of all, this is a Jupyter notebook. The advantage of that is we can do this ahead of time and we can walk through step by step and see great, nice little graphs, nice little data sets, and all of that, and walk you through every single step. And we can save it for later too, and it's shareable. So that's why machine learning people are in love with Jupyter notebooks. So I'm beginning to use it as well. And if you want to know how to install or how to do a simple one, just watch my videos from a few days ago. All right, so first we do is we import three libraries. First one is NumPy. It's really wonderful for any number stat type functions. Then we import pandas, which is a great one for manipulating data or dealing with data. Then we use a third one that will help us plot the numbers so we can see step by step what's happening. Next, what we're going to do, we're going to, from these library sets, we're going to import a certain functions, I think, or methods, so that can be used later on. The other one we're using is from SQL and SQL Learn. I don't know if it's SQL or SKI. Anyway, it doesn't matter. It's a library, public available, open source, free. Anybody can use it. And when you install Jupyter Notebook, it automatically gets installed, so we don't have to install anything. It's already there. We import some of these libraries as well to do the rest of the work that I'm going to show you in just a minute. All right, first thing, we're going to actually load a data set from a CSV file. Very simple. It's just a data set with two columns, X and Y, because we're going to use linear regression to see how our model actually performs. The reason I chose that is because it's very simple to see and visualize. Now, linear regression, I haven't done a video on that yet, but it's actually very simple. If you have an X and Y plot on the graph, which you will see in a minute, you want to find a pattern through machine learning, what the relationship is between X and Y, so that if I give you another point of X, you can guess what the Y value should be. So that's the whole point of a linear regression. All right, so let's go back up again. So we import the data into a variable called data from CSV file. Here's the CSV file, just to show you what the CSV file, well, the CSV file is just one number, comma, another number, 1, 2, 3, 4, so on and so forth, just like a CSV file with two columns. If we print the variable data, you see what the data looks like. It's basically a two-dimensional array with these numbers like that. So if you can imagine 1, 2, that's what's in the CSV file. So we imported the content of the CSV file into this array. Next, we're going to grab all the X values into a variable called X. And we're going to print that out, and you see these are all the X values. Next step, same thing for Y. We're going to take out all the Y values from the data variable and put into another variable called Y. Now, just to visualize the data, we're going to use one of those libraries that we imported earlier with this little code line. PLT is what we called the library when we imported it, and then plot is the function we're going to use. And we feed X and Y, and just you would notice that X is capitalized, Y is not. I think it's like tradition in machine learning, but anyway, I've seen that before. All right, so if we do that, we actually see the data set, how they line up. When I put the data in, I intentionally made them a little erratic, so it doesn't become a straight line. So that's what the data looks like originally. Now we're going to use another library, train test split, to split the data into two parts. You would notice I put the variables X and Y and test size 0.5. That means take the data that's in X and Y and split them into two randomly. which is why if we run this a bunch of times, the results will be different because it's randomized, right? So, but for each one though, we're going to have half the data in for training the model, and the other half will be used to test the model. All right. So if you look now, we have extra. This is the training data set. So you see that this is half of the data set that we had, and this is the training data set for the Y. This is this data set for testing, and for X, and this is the test data set for Y for testing. This is the data that the model doesn't get to see when it's trained. This is how we're going to test the model to see how good it is. Next step, we're going to actually call the model, and we're going to call the fit function using the training data, X train and Y train, for the model to figure out what's happening with the trained data, actually start predicting. All right, so let's run this. I think everything else is okay. I may have to run the other steps as well. I forgot to do that, but it's not complaining, so we're going to keep going. So basically, what you're supposed to do, you're supposed to run each step to make sure that there's no failure in between. But it looks like we're okay because I already ran it in the past. Now, with doing that, what we got from this line over here is we get the data set for the prediction. No, so sorry, we're going to actually grab the data set using the model. So here's the data set that we're going to predict using the model and using the predict function and passing it the X data set, because remember, X is the independent variable and Y is what we're predicting, right? Then we look at the result in a text format. We see these are the Y values it thinks we're going to get based out of the X values we chose randomly from the testing data set. All right, next step, we're going to see how good our model performed, right? So we're going to calculate the mean squared error. Means for each predicted value, we're going to take the distance from the actual value and square it so that the signs don't matter, and then sum them all up to see how far apart we are from the actual numbers. Our model is from the actual numbers. And the other thing we're going to measure is we're going to measure something called the R2 score. This is the score that really matters. It tells us how close we are, how good your model is in predicting these numbers, right? The first result, the number depends on the absolute value. So the absolute number doesn't mean anything in this particular case. For example, here our result is, we need to run this. We didn't run that. So let's run all these commands. Let's run this step. We got that. Let's run this step. We got that. Now we get the result. We get the result, which is 9.5. That means, remember, this is squared. So if we took a square root of that, it's 3 something. So on average, from this data set, from this line, right, on the testing set, we are about 3 away from the actual value. As you can see, that number doesn't really mean anything in this case because some of the numbers are very small. So what is 3 is average, so it doesn't mean anything. What does mean a lot is the second result, which is the R squared value, and that is 0.91. That is pretty darn good. For scientific measurement, generally you want 0.95. For something, even 0.3 is okay. So it really depends on the use case. But because the fact that we got 0.91 is pretty darn good. So our model that is used in this library did a pretty good job based on the 10 numbers, right? Now, I will prove to you that this was random because if we run this, not this step, I'm going to run, this is all the original data. This is where we generate we pick randomly, we divide randomly our data set into training and testing. So if we run that again, we're gonna get a fresh set of picks from the numbers, right? And let me run it again. See, for example, here we have 20, 11 X values. We have 20, 11, 5. That should change. So if I run this again, there you go. It's 18, 10, 7. So it's randomly picking those numbers, right? So if we do that, if you go all the way, now we have to run the model again. These are all Python code, by the way, nothing special. So we're gonna run the model and run the fit again, and we're going to test our model again. And this time we got something didn't work right. We got 198. That doesn't make a lot of sense. Something went wrong. So let me try this again. Da, 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 da. Okay, maybe skipping the step is not a good idea. So let's run that. Let's run that. Yeah, I think these results are from the previous times. It's all messed up because of that. So each run, we really should run all the steps so we get the fresh data evaluated. Run that again. Pick the model again and run the fit again. And then we run this again and we get these numbers. And now we should get a better result. There you go. Now this time we got 12. So this time the distance from the actual numbers is a little bit higher. It's 12. So square root of 12 is more than 3. Last time was 9.5. So went up a little bit. Also, our result, the key number, the R square value is 0.85. It's less than last time, which was 0.91. So in this particular run, the model didn't do as good a job as it did the first time around. This is called variance, which we will talk about in a different video. The same model with different data sets, as how widely it varies, its performance is called variance. But that's a whole different topic for another day. So again, the point of this video is to show you end-to-end using data how to run a model, in this case the simplest model possible, simplest machine learning possible, called linear regression. And I'll keep making these videos so we can have videos of all the possible algorithms that I could write code for, and hopefully you can see and get value out of it. All right, if you like the videos, please like and subscribe. I will see you next time.